Alright, this is lesson 1.4 for our Pre-Calc 12 class. Unit 1 is called Functions and Transformations. Lesson 4 is called Parent Functions. In this lesson, we're going to learn what is a parent function, and we're also going to expose you to a bunch of different types of parent functions. Some of them might be familiar, and you can recognize them from previous math classes. The hope is some of them are new and strange and foreign and maybe never seen before. If that's the case, don't panic. We're just getting a brief overview, recognizing different curves right now, and just giving an idea of what's to come. Alright, so a parent function is this. It's the simplest form of a function of a family of functions that preserves the same shape on a graph, more or less. So there's 4 f functions on this list right here. There's f of x equals x squared. There's f of x equals 3 times x squared. F of x equals 3 times the quantity x plus 1 squared. And there's f of x equals 3 times the quantity x plus 1 squared minus 5. If I graphed all those shapes, all those functions would graph as a parabola. The parabola may be stretched or compressed, flipped over the x-axis, y-axis, maybe on its side, rotated. However, it'll still always be a parabola. So these f functions all share the same parent function. And the parent function is at the top, f of x equals x squared. So that is our first parent function right there. And all these other functions are in the same function family as that parent function. We also have 4 g functions over here. We have g of x equals sine of x, 3 times sine of x, 3 times sine of the quantity x plus 1, 3 times sine of the quantity x plus 1 minus 5. And so these all have the same wave shape, and so they fall into the same function family. The parent function is the most simplest form, sine of x. So sine of x would be the parent function of this function family. Alright, we're going to go Desmos and play with some graphs. First 3 functions, and the ones you're most likely to have seen before. We have linear functions. I can change the shape of this thing. Where's my A? There it is. I can change the shape, but it's always the same basic shape, just moved around. I can look at our x squared again. Like I said, no matter what I do to this thing, it's always going to be a parabola. Unless I make it 0, of course. And it's linear. Y equals 0. I can do cubic. Y equals x to the power of 3 is a parent function. And I can stretch and flip that one around. Let's make this a negative. Make it negative. It flips it, but it's still the same basic shape. If I work with some other functions, so we've got radicals. I can flip this one. Look at that. Boom. This is what a square root function looks like. The parent function being y equals, or f of x equals the square root of x. I can do a cube root function. Ooh. Looks kind of like a x to the power of 3 function, but it's on its side. Do an exponential. We'll do a unit on exponential. Exponentials only work with positive a values, so we'll keep it in the positive. Here's what it looks like. And as we discovered today, David, that if we played this, move this curve around while listening to the Guardians of the Galaxy playlist, it could be quite mesmerizing. If you like pina coladas. Anyways. Alright. We have some rational ones. So here's a rational function. Ooh, pretty. 1 over x. 1 over x squared looks like this. I can stretch that thing and move it around. That's pretty cool. We have logarithmic functions. So logarithmic functions look kind of like exponential, and the reason is because those two things are related, but it's slightly different. Let me pull up exponential again. Yeah. Do you see the relationship? If not, it's okay. We'll unpack it when we get to those units. Alright, and we have some trig stuff. So here's a sine wave. Ooh, I can stretch that one. Stretch it this way too. Boom. Whoa. Notice sine always starts at the origin. Why that is, we'll get into later. But no matter what I change a to, sine to one. That's pretty cool. I could do cosine. Notice cosine looks kind of like sine. It just doesn't start at the origin or the center. It starts at the top. When x is 0, it starts at the top of the wave. That's never going to change with stretching. Anyways, those are a bunch of parent functions. Let's go back to previous screen. Here are all those parent functions we just looked at. All of them plus an absolute value. I didn't show you the absolute value, did I? Man. Absolute value, let's put that one up here real quick. Equals the absolute value of x. Here's the absolute value function. And we can stretch that one around. Ooh, ready. No matter what I do, it's always a v. That's fun. Alright, enough playing around. So here's a list of all the parent functions that we just looked at. At this point, I just want you to kind of be exposed to the graphs of these functions and the expressions themselves. Don't panic about not knowing much about them. We have a whole unit on rationals we're going to talk about. We have a whole unit on logarithms, a whole unit on exponentials, absolute values. We have a whole unit on trig. We'll get all into that stuff this semester. The stuff that I'm hoping you have some familiarity with are linear and quadratics for sure, and then potentially a little bit about the expressions for radicals. Maybe the graphs for radicals will be new, but maybe hopefully you've seen the expressions before. All right, your homework assignment for this is going to be identifying the expressions of parent functions that go with a graph. So it's going to be straight up, here's a graph, which of these 4 parent functions, multiple choice, best fits this graph shape. And that's all you got to do. Hopefully it's not too crazy. Don't stress out about the fact that there's lots of stuff you don't know about those functions yet. Like I said, we'll go over more in depth later. But at this point, hopefully you're exposed to a bunch of different type of parent functions, and you know what a parent function is.